This conference will now be recorded.
Right. So yesterday we were talking about the DevOps overview, a big picture we have discussed, and we were talking about this pipeline, correct? So this is the pipeline we were talking about. And if you see here, the first stage, developers are writing the code and placing the code in a version control system, right? So once they place the code in version control system, as a DevOps person, we need to automate pulling the code and building it. What is meant by building it and all we'll see in detail. So first thing is, as a DevOps person, we need to automate pulling the code whenever developer add a new change, right? Let's say there is an application, there is already some code, a new feature is added. So whenever a new feature is added, means whenever some code changes were done by developers, it should automatically trigger the pipeline. It should automatically start the pipeline, right? So whenever developers write the code and place it on Git, so this may happen multiple times in a day. Like developers keep on writing the code, right? Like they may be developing a new feature, they may be fixing the bugs. So they'll write the code and place it in the version control system like Git. So once they place the code here, we will create a system or a pipeline which will automatically start and pull that code, pull that new code, build it, test it, deploy it, and monitor and so on. So we have to start pulling the code and trigger the pipeline with the code changes developer does, right? So to understand this, we need to learn Git, right? As a DevOps person, not only that, right? Another reason for learning this version control system is, as a DevOps person, we'll be working on many configuration files, right? Like Terraform config files, Kubernetes files, and so on. So even these files are to be version controlled, right? What is meant by version controlling? I'm going to explain. So in that perspective also, we need to learn Git. So that's the reason we are going to learn Git now, version control system. So that's the first tool in the pipeline. So the agenda is we'll be learning Git, right? We'll be spending some couple of hours, maybe today, tomorrow, for maybe 4 to 5 hours on Git, wherein we'll be learning Git thoroughly. Am I not audible? Hello, am I audible for everyone?
Yeah, you are.
Yeah, yeah, you are.
Okay, please check from your end. Everyone can hear me. Umesh, please check from your end. Right, so that's the reason we are going to learn version control system. So that's the first tool in the pipeline. We will spend some couple of days here on Git. Okay, we'll be learning Git from the basics till advanced concepts, and we'll do complete hands-on. Like I said, we'll begin every tool from the basics with the architecture, then the commands, then the scenarios, right? So that we'll be ready thoroughly for to work on Git and handle any interview questions on Git. So the same in the same way we'll follow for every other tool, right? We'll be working on each tool in the same fashion. So let's get started with Git. Once we learn Git, we'll also use it in the pipeline. So let us try to understand what is a version control system. So yeah, many of you might be using the version control system. There were so many version control system, but yeah, let's try to understand this in more detail. What is a version control system? See, to understand this, let's take a simple scenario, right? There is a, let's say there are a team of developers, okay, who are working on a project. There is a, like a, let's say some hundreds of files were there. Okay, let's say this is the directory or a folder which is shared across multiple developers. See, I'm explaining a scenario wherein no version control system is used. Okay, so there were so many files here in this folder and multiple developers are working with these files. Let's suppose there's a developer A and developer B. Okay, there is a file called file1. Okay, let it be whatever be the file is. They might be writing programs in Java, C#, Perl, PHP, Python, or it could be a simple text file, whatever it is. Our intention is not to learn any programming here. Our intention is to how to version control the files. So there is a file here where the team has to work. Right, let's suppose developer A has to work on it. Okay, this developer A has downloaded this file or got this file to his local computer, and he was making changes to this file. At the same time, developer B also got this file. He was also making some changes. So once they make the changes, they have to put the file back, right? This is like a shared folder or remote directory where all the project code is available. So developer A kept his file back on, let's say, day 1, right? And developer 2 kept his file back, or the same file back, on day 2. So finally, file 1 on this remote will have which person changes? Both of them got the file at the same time. Then developer A made some changes and put the file back, right? On day 1. On day 2, let's say on Monday, developer A kept his changes. On Tuesday, developer 2 kept his changes back. So finally, this file 1 will have which person changes?
Day 2.
Developer B's changes, isn't it? Day 2, yes, developer B changes. Because what is happening? Simple logic. These changes are overwriting the changes of developer A. Am I correct? Yeah, changes are being overwritten. One person changes are overwriting the others, right? Developer B doesn't know this is happening. He doesn't know this is happening. He's not doing it wantedly. Similarly, developer A doesn't know, right? So if this keep on continuing, at some point of time, the project gets corrupted, messed up, isn't it? There might be 10 developers working, right? They were just making changes, placing the changes back. If this keep on continuing, the project gets corrupted. So how to take care of this? See, each developer will be working on the client requirements. They'll be working on the logic. They'll be writing the code. They don't have time to check whether their files are saved properly, whether someone is overwriting it or not. So how to handle it? Yeah, means multiple developers working on the same file at the same time. They're working on the same file simultaneously. So how to handle this scenario? This is a scenario without version control system. So that's where again version control system comes in, which can allow developers to work simultaneously, right? Simultaneously, parallelly, right? So that they can work on it. What version control system does is it helps developers, right? So that they can write the code without getting overwritten, right? A version control system will not allow overwriting. It will inform us. So that way it will help us. Not only that, let's suppose developers are working on this file 1, which is a version 1. Client came and said they want some modification, they want new version, right? Suppose, let's say they have overwritten this version 1 and made version 2. After 6 months, let's say this new version is not doing good. Client want to go back to the version 1. But you have, like, developers have overwritten and made version 2. Don't ever do that. Okay, you have to maintain versions. Maintain version, keep V1, then create a copy and like maintain another version, but don't overwrite the old versions because we may need the old versions later at some point of time. So maintain versions, right? Means maintain backups. Don't ever overwrite the code. Maintain versions, maintain backups of the code, right? So this can be taken care by version control system, right? Particularly maintaining backups, maintaining versions, right? Also, another important reason, maintaining logging of the things happening, right? Let's suppose some person made some changes and application got crashed. Application is not at all available, right? If that is the case, business goes down. We want to immediately revert those changes. When something went wrong, we need to put those changes back immediately. How do we know what happened? So a detailed logging is very important. We need a system which can provide this detailed logging. Like detailed logging, like, okay, file 1 was modified by developer B at 7:30 a.m. That's why application crashed at 7:40 or 7:35, right? Also on line number 8. This kind of detailed logging is necessary, important, so that you know what is happening, which person is making what changes and all. Correct? So even this is possible with version control system, right? These are all the advantages. So developers, they'll be working on writing the code. They cannot work on managing the code, saving the code properly, whether it is saved properly or not. All these things they cannot work on, right? That's where version control system comes in. Okay, those files can be any files. There can be any programming files, irrespective of which programming it is. It could be any file, right? That's how developers use it. Like, it is mandatory for developers because they keep on writing the code. Definitely, they have to use some version control systems. Even testers use it, right? Because they do write a lot of test scripts. Now automation testing came in, they do write a lot of code. Even DevOps persons use it, right? Because like I said, we have a lot of Terraform config files, Ansible playbooks, and so on. Even we need to manage them, right? So this is how everyone in IT will be using version control system, and everyone getting into IT should have knowledge in this version control system. Okay, this is from the perspective of maintaining the files. As a DevOps person, we'll be also using it in the pipeline, right? How to use Git in a pipeline, that also we'll learn. First, we'll learn with respect to version controlling, then we'll learn with respect to integrating it in the pipeline. Am I clear? Am I making sense?
Yes.
Any questions from anyone? Any confusions? Still anyone have question why a DevOps person should learn this? I'm not a developer. Still anyone have that question, or is it clear?
I don't have a question, but I wanted to add that can't you also do revert last commit if one person overwritten the code or something that brought someone's application down?
Yes, we can also override the changes. See, we will do all those scenarios. Okay, we are going to do hands-on on all those scenarios. Yes, we can revert those changes, right? And yes, we are going to execute all those scenarios practically with hands-on, right? So, hope that answers your question. And yes, version control system is the one which helps developers or any team to work simultaneously on the same file at the same time. It helps you maintain the versions. It helps you maintain the backups. It helps you maintain logging, right? Which provides a detailed history of which person made what changes. Because if something went wrong, we can revert those changes. Like let's say here, developer B made some changes to file 1 at 7:30 a.m. on line number 8. Okay, if we don't need it because this line is crashing the application, this code is not working properly, we can undo it, we can revert it, right? Means we can go to the previous state. Yes, that is possible. We will do all of these scenarios. Okay, how to maintain versions, how to allow developers work simultaneously, what happens if people are working simultaneously, how it prevents overwriting, all of that we'll do with hands-on, right? Hope you all got a good understanding on what a version control system is, right? There were again different types of version control systems. They were categorized actually based on the architecture. They were categorized as centralized version control systems and distributed version control system. Okay, let's talk about centralized version control system. See here. So like I said, depending on the architecture, this classification was made. So this is a remote repository where all the project, all the code base was there, right? See, this could be a developer project or DevOps project, whatever it is. Let's say DevOps, right? So this is a remote repository where all the Terraform config files were placed. Okay, this is the remote project location and working copy. These are the workstations of individual DevOps persons. Okay, DevOps person 1, DevOps person 2, DevOps person 3, right? So everyone will be connected to this remote location. If they have to make any changes, they'll get the changes to the local, make the changes and put the changes back, right? This is our centralized version control systems work. They connect to remote and work on it. So there is a drawback with this kind of architecture. See, for some reasons, if there is no network connectivity or network disconnected, right, entire work will be halted. They cannot work on it because they were connecting to remote and working on it. So this kind of architecture definitely needs network connection always, right? That's one of the drawback. And another drawback is if for some reasons this remote repository is lost or crashed or gone, something went wrong, chances of recovery are very less because it works like a single source of truth, means you are having all the code base at one location, right? So this is the simple architecture of centralized version control systems, and these are the drawbacks. There are which tools comes under centralized version control system? There were so many version control systems. Out of it, SVN, TFS, Fairforce comes under centralized version control system architecture, right? So to overcome the drawbacks of the centralized version control systems, we have got distributed version control systems, right? This is the distributed version control system, and yes, Git falls under this distributed version control system. Git, Mercurial, Fossils comes under distributed. These are some of the version control systems. Okay, there were so many version control systems, and our Git, which we are going to learn, comes under distributed architecture, and majority of the modern DevOps projects uses Git, right? So distributed architecture helps you to overcome the problems of centralized architecture. So let me talk about this now. So in distributed version control systems, yes, you'll have a remote repository. Also, let's say this is the workstation of each DevOps person or each developer, whatever it is. Okay, so this is the workstation of each person, and this is the remote repository. And in distributed architecture, there'll be two repositories, remote repository and local repository. Means every developer or every DevOps person, every team member will have a copy of remote repository into their local machine, which is called as a local repository. Means exact copy of remote. And they will not directly work on it, rather they'll be working on another directory called working copy or working directory. Means some folder, some other folder. If you are Windows person, directory is nothing but a folder in Windows terminology. So they work on another folder. Then if those changes are working fine, if they want to make it available for others, they'll have to push it to local, then from local to remote, right? So it's like a 3 steps before the changes goes to remote. Only when the changes goes to remote, means only once you place the changes on remote, others can see those changes, right? Those changes will be visible only for you until you push them to remote. If they are on local, they are only visible to you. Others cannot see them, right? So this is how remote distributed version control systems work, and this overcomes a lot of problems. See, only to push and pull you need remote, you need network connection, right? But majority of the times we work on our local repository. We work here. Once the changes are fine, once we confirm, then only we push. Or else when there were some new updates on remote, we pull and get the new code, right? These are less frequent commands. Pull and push are less frequent. Majority of the times we work on local. Once everything is done, we push all of them at once, right? So push or pull are less frequent. Means you don't need network connection all the time. You can, even though there were no network connection, network disconnected, you can still continue work on local. Once network restored, you can push the changes. Code will not be overwritten in any version control systems. Okay, not in distributed, not in version, not in central also. How that works, how can code not override? We will take up those scenarios. Okay, we will do hands-on to understand how it works. I'm giving you the architectural overview. Okay, and then we'll get to the hands-on. Am I clear with every point here? Is the architecture clear? So yeah, developer one is working on his local, then he pushes changes to remote. Same is the case with developer two. He is working on his local, once he's done, he pushes his changes to remote. But how to prevent overwriting? Isn't it developer one, developer two, both are pushing to remote? Are their changes not getting overwritten? Definitely they'll be. How and all we will see. Okay, we will take up some scenarios and we will see with the hands-on, not theoretical discussion here. Okay, we will do it practically, right? So yeah, even though network connection is not there, you can still continue work. And also, let's say like this central server is crashed, like in centralized version control system, this remote repository or central repository, whatever you call it, this is crashed or lost, right? Still chances of recovery are more, because see, every person is having a copy of remote, right, which is a local repository. So they can restore from there. So chances of recovery are very high. Understood the distributed version control system? Any questions from anyone? Git is a version control system, Kushwant, and GitHub is an online management system to host your version control systems like Git. What exactly it is, we'll discuss. Okay, maybe by end of today or tomorrow, you'll get a clarity on this part. Means in simple, GitHub works like a remote. Okay, Git is your local. In simple. Technically, Git is a version control system and GitHub is an online management system. Okay, like you can have a user interface where you host your local repositories, like where you pull your local repositories. Any more questions in this part? Okay, so that's how distributed version control system works. And yeah, like I said, there were so many version control systems. And yeah, like I said, depending on the architecture, they were categorized. So Git is a distributed version control system. And yeah. So yeah, you can see the graph of different version control systems like SVN, TFS, fossils and all. You can see Git. There's a report from Google Trends from 2020. You can also get the latest graph, right? Git is very widely used than any other tool. So we are learning it. See, we are learning the tools which are market leaders, right? So majority of the projects are using it. Also, if you know Git, you can work with other tools very easily. They're all similar tools, we can say. Like every category, like version control system, there were so many tools. You need not worry about which tool to learn and all, right? You can learn one tool, expert or master one tool, expertise on Git, master on one tool, that will do. So we will be working on Git here. So yes, this is the architecture of Git in particular. It follows the same architecture, right? It follows the same architecture of distributed version control system, but let's look into that in more detail. So yeah, like we discussed, it will have two repositories, right? Remote repository and local. So this is your local repository. Right? This is your local repository. One second. Okay, so now this is a remote, and now if you see here directly, this is a workstation of a individual developer. Okay, now this is a local repository. They'll not directly work on local like we discussed. There'll be one more directory called working directory. Okay, they make changes on working directory. Again, once they make changes on working directory, they cannot just push this way from working to local. No, this is not allowed. Then how does they do? They have to move the changes from working directory to staging area, from staging area to local. Once your changes are available on local, they can push those changes to remote repository. And what is the staging area? See, this is like a virtual layer or else an index area. Before you move your changes to local, you have to move your changes to staging area. Right, you cannot directly move to local. You have to first move them to staging, then from staging to local. This staging area is also called as index area. It's a virtual layer. And why should we do it? Is the staging area having any importance? Yes, it works like a preview or else a pre-check before you move your changes to local. Not only that, it will help you to have a better control on which changes are going to local. Let me give you a simple example. See, we will be installing Git. We'll be doing complete hands-on. We'll see what is staging area, what is working directory and all. Right? This is giving you help you get some overview of it. Right? So let me give a simple example. See, let's say you have 10 files. You are working on some 10 files. Okay, out of the 10 files, you just want only 5 files to be on local because only 5 files work is done, completed. So only I want to push only those 5 files to local and then to remote. So meaning I have to add only 5 files here, not everything, right? So whatever in the staging area, when I run git commit command, there were so many commands. So with this command, whatever in the staging area, I can move to local, right? So it will give you better idea, better overview, better control on which changes are going to local. It's like a preview or else pre-check before you move your changes to local. Got it? And once you move to local, yes, you can move them to remote repository. Am I clear? Right? How to create local repository, how to create remote, all of these things we will discuss. Understood this part, everyone? Yeah. And here, let me give you some understanding on how local repositories work. Let's say this is the local repository. How to create a local repository? Say there are different scenarios and use cases how local repository can be used. Still, there should be a staging area before remote repository, right? Before remote repository, see whatever is in your local repository, whenever you run git push, whatever in local repository will be pushed to remote. Local repository is our version control system, right? Before you place it in your version control system, we need to do a pre-check, not after placing into local repository. And this is how the Git architecture is. This is not how we are designing or we are planning, right? Whatever changes you have in local repository, whenever you run git push command, those changes will be pushed to remote. And coming to local repository, okay, how do you create it? Yeah, there are different scenarios and use cases. Let me explain you. Let's talk about the first use case. Let's suppose it's a new project. Okay, they were starting a new project. Let's say a DevOps project. They want to have some Terraform config files and all. It's a new project. There was nothing. It was new team formed, new DevOps team formed, a new project. So you can create this local repository manually with some commands like git init. I'll show you. We'll run these commands. Okay, so don't worry. This is just some understanding. So you can create a local repository manually, an empty one, then put the Terraform config files there, then add it, commit, like you have different commands, right? You add it, you commit, and then you can push to remote and create a remote repository. That's how you can do. Or else another use case is, let's say project is already there. Okay, project is already there, DevOps team is already working. You joined the team as a new member. It was some, let's say, 4-year-old project. You joined the team now to make some changes on Terraform config files. So meaning already remote repository is there. Okay, you can copy from that remote repository and create a local. That's another way to create a local repository. Understood? Create a local by copying from remote. If already remote repository is there, you can copy from there and create a local. Or else, let's say there is no remote repository, it's a new project. You can create local repository from scratch and push to remote and create a remote. Got the scenarios, everyone? We will execute both the scenarios. Okay, we'll start with the first scenario first. Assuming it's a new project, there's nothing on remote, we'll create a git local repository. Okay, develop it, then push to remote. And also then we'll take up the second scenario. Clear, everyone, how local repository can be created? These discussions are important. As we go by, we are going to execute, we are going to do practicals on these scenarios. Clear, all of you? I want to have response from everyone, each and every one of you. Clear?
Yes.
Yes.
Right.
Yes, it's
So how to do it? How to create a local repository manually, like an empty repository, and then develop. Okay, how to copy from remote and create local. All these scenarios we'll see. Okay, so this is one thing. And another interesting thing I would like to mention here. This may be a bit confusing, but really interesting. Okay, these basics one should be very clear with. Generally in projects, we see people working on Git, they do a lot of commands, they do a lot of commits, they do everything on Git. but lacking this kind of basic knowledge. If you don't have this basic knowledge, right, you can't be strong, you can't troubleshoot the things when some error pops in, right? So let's have the clarity here. See, we were talking about local repository working directory. I told you it's nothing but a directory, a folder in your system. So here, strictly speaking, this working directory, local repository, is physically one and the same folder, same directory. Then you may be questioning me, why are you saying then working directory and local repository? Logically, they are different. How is that like, right? How logically they can be different? See here, let's suppose this is your, this is a folder, okay? This is the local repository or working directory, whatever you call it. Suppose I went into this folder and I have just created a file. Okay, I didn't run any command, I just placed a file there. Means this file is set to be in the working directory because I just created a file, that's all. Then suppose if I add this file with the command git add that file name, then we say it's in the staging area. Then later, if I do git commit on this folder, then it is set to be in the local repository. But physically, the file is in the same folder. Am I making sense? Right? Means depending on the status of the file, status of the changes you are making, we call it as a working directory, staging area, and local repository. Physically, it's one and the same directory. Got it, everyone? And if you want to move your changes to remote, you should be doing commit on the folder, then only you can push to remote. Got this part, everyone? How logically it's same, how physically it's same and logically the folder is different? These concepts are very important. You should have clarity on this. There should not be any confusion like which is staging area, which is working directory and all, because many people will have this. Okay, so this is one thing you have to make a note of. And the other thing is, okay, fine, local repository is ready. Now I want to push to remote, I want to share with the team. See, as long as it's a local repository, those changes are confined only for yourself. Your manager cannot see them, your team members cannot see, cannot use those changes, right? If others have to see, means you have to push to remote. What is remote repository? That's where GitHub comes in. GitHub, okay, Bitbucket, GitLab, all of them can work like a remote repository. What is a remote repository? Now it's an online management system. You can open it on the browser, right? It can host your local repositories like Git or even any repositories it can host, right? So it works like a remote repository, GitHub. So we'll be learning Git and GitHub thoroughly. If you know GitHub, you can work with Bitbucket, GitLab, and so on. In earlier project, we used to use GitHub. Now this project is using Bitbucket. So it's quite comfortable, both are same, right? So let's begin with the local repository. First, let's begin with a scenario, creating an empty local repository. Assume that it's a new project. Okay, let's say we are all a team. It's a new project. There's nothing on remote. We have to create a local repository. Everyone can create a local repository and push to same remote, right? How this works and all, we will see. So yeah, let's begin. First, we have to install Git and start working with it. Good to go. We are going to start with the hands-on now, with the practicals. Good to go. Any questions, concerns from anyone? Anything you have? Like,
Yeah, doesn't everyone need a GitHub account first?
Sorry?
Doesn't everyone need a GitHub account first?
Okay, GitHub account. You can have a GitHub account, a free account later. Okay, today we'll be starting with Git. First, we'll master Git. We'll do Git thoroughly. Then you can have a free account on GitHub. I'll talk about it. Okay. Until then, we'll first work on Git. There are many things we have to do on Git before we go to GitHub. Until then, we don't need it. Okay. So now, yeah, let's install Git. And Git works on multiple operating systems. You can install Git on Windows, you can install Git, you can use Git on Linux, you can use it on Mac. So irrespective of the operating system, you can use Git. And whether you use it on Linux, whether you use it on Windows or Mac, It works the same way. Means commands are same. Installation setup may be different, but commands concepts are same. So first we'll get started with our Windows or Mac, whatever you have. Okay, we'll get started on our local machine on our laptop. All right, once we learn it, then we'll see implementing it on other operating systems like Linux and all. So first install Git. Git installation is very simple. Let me show you. Just go to Google and type in install Git. Right, you should be going to this official documentation gitscm.com. Right, and here you will have a downloads. See, depending on your machine, depending on your local machine, like whether your laptop is Windows or Mac or Linux, choose it. Anything, it's very simple. Okay, if it is Windows, just go here and you will see the download option. Depending on the bits of your operating system, either it is 32-bit or 64-bit, you can click on it. You will get an executable download. See here, if I click this, see, I'll get an exe downloaded. I'm canceling it because I already have done that. Once you download the exe, run the exe. That part I believe everyone know, downloading an exe and running an exe, right? I'm not doing it because I already installed it, so I could not do it again. It's just a few steps you have. One second. Also, yeah, this is the drive all the registered students might have got access to. Okay, this is the Google Drive I'm sharing where you will have all the interview questions, sample resumes, audio files is in another one that also will be shared. So coming here, you have a folder called Git. Right here you have all the commands, installation, everything. So Git additional references, like even the links I'm using are also placed here. Okay, Git SCM link, which I'm using. So there you don't need to struggle for all these steps, right? And Git installation on Windows, you have everything here, including the screenshots. Once you download the exe, it will show you this way. You have to just run the exe and Git will be installed. You can run these commands from the command prompt to check Git is installed. See all the steps I have placed here. This is an executable in the downloads folder. Run the executable.
What about Mac operating system?
Mac, you can follow the steps here if it is Mac. Brew install git will do. A simple command, brew install git will do. That's all for Mac, right? And for Linux, m install git. If you are using Ubuntu distributions, apt install. If it is a Fedora or a Red Hat, m install. Okay, we will also install on Linux later. But yeah, you have everything here. So just click on, keep on hitting next on that wizard. It will launch a wizard when you run the exe. Okay, you can just click on next, finish, and go through this wizard. So once you navigate through all the steps, finally, you can see it completes the Git setup wizard, right? Once it is finished, how to launch Git, right? So just go to the start menu and run the command git bash. Means whenever you install Git, this git bash will be installed. It provides you some bash environment to run Git commands. Okay, so that's all is Git installation. You can do it after the class. Okay, as it is day one, you can do it after the class and you can listen now. All the commands I'm using, all the steps will be shared in the group chat. Okay, so yeah, Git is installed. Now you can check on this Git bash also, Git version. Okay, so fine, we are all set. Okay, fine, now we have Git installed. How to version control any projects, any folders, right? So let's talk about it. And one more thing is this Git bash provides a kind of like provides a Linux environment. Like you can do everything from the command line, like from the command prompt you do, right? You all might have known this command prompt, right? The same way you can use here. Okay. And also this will help you understand basic Linux commands, right? I just want to version control some folder here on the desktop. I'm creating a folder here, new folder, let's say git demo. Okay, this is the folder I want to make as a local repository, and I'm planning to put all my project files here. Means Git should version control this, correct? So how do we tell Git to version control this particular folder? Because there were so many folders on my system, so many files, which files Git should version control, correct? So we should tell Git to version control it. What we should do is, you can go to this path from the git bash, copy the address, go here, cd, okay, go to this folder. See, it shows you the prompt here. You are in this folder. Now, in this folder, they say this is the git folder. I want to make a local repo. So go to that folder and run the command called git init, right? So this git init means it will initialize Git. It will start Git, means it will create an empty local repository. Then Git demo becomes a local repository, right? And whatever files you place in this folder will be version controlled by Git. So I'm repeating, whichever project you want to get version controlled by Git, or else whichever directory you want to make a local repository, go to that folder or go to that directory by cd command. CD is a simple Linux command, change directory. If you have used command prompt, you might have known that, right? Go to that folder and run git init. See, it says initialize empty git repository, right? It was showing .git, means yes, local repository is created. Now this git demo is nothing but local repository. It's a local repository, means now if you keep on placing any files here, all of them will be version controlled by Git. Okay, you could also show here, we didn't learn Linux, I'm assuming we don't know Linux. Okay, we will learn Linux separately. Until then, you can do from the user interface this way. Just let me open this. Okay, here you can go to view and view the hidden files, right? You can see .git folder is created, but initially it was hidden. You can go to view menu and select the option to see hidden files. So .git is created means yes, this git demo is a local repository. That's how you can identify local repository. Local repositories will have .git folder. .git folder will be created when you do git init. Okay, so yes, this is a local repository. Okay, fine. I have created local
But,
repository.
but this is also working directory also.
Yes, that is also working directory also. How I'll show you. Yes, the same is the working directory. This git demo is a working directory. This git demo is a local repository.
No,
Okay.
what I'm asking, like before running the git init, is it a working directory or after running only this is a working directory?
No, after running only. After, otherwise it was just normal folder in the file system. Okay, after running git init, then you can call it as a local repository or working directory.
Okay.
Okay. So, okay, fine. Let's create some files. I'm creating a file, a new file. Okay, a simple text file I would like to create file. See here, like I said, our intention is to learn Java coding or writing Terraform config files, and Terraform config files we'll write later. First, we'll see version controlling file. This file could be a Terraform config files. With respect to developers, it might be a Java program file, whatever it is. First, learn version controlling it. Then we'll see how to create Terraform config files. Okay, I have created a simple file. Some time back we have discussed, right? If you just created a file means, what do you say? Where is it? I just created a file called file1.txt in this folder git demo. Now tell me, is it like, can I say this file is in working directory or staging area or local repository? What should I say? Working directory. Working directory, right? But how to confirm? Can I confirm? Is there any way I can confirm? Yes, we can confirm by running a command called git status. Okay, git status will tell us like what is happening to the file, what is happening to your repository. So when I run git status, it tells you ignore these things for some time, come here. untracked file means Git know there is a file. See, it's already text file. I have given extension, so it was showing. Ignore it, okay? Because we are not bothered about the file. Some file we need. So it was saying untracked file means Git know there is a file, but Git is not tracking it. Why it is not tracking? It is asking us use git add so that Git can track. Okay, see, it just file create, it's in working directory, means Git cannot track. You have to do git add. So what I'll do, git add file name, right? Now run the same Git status. It tells you changes to be committed. Can you tell me where is this file now? Where is this file one?
Still in your local folder.
No, you see this picture and tell me where is this file now? Earlier
In
it was in
staging.
working directory. Now I run this git add
Staging.
command. Staging area, it was in the staging area, but physically it is in the same folder. If you see the folder here, it was in the same folder. Am I correct? It was still in the same folder, but now I'll tell it's in the staging area. Making sense now how the same folder can be called as a working directory, local repository, right? Physically it's same, but logically it's different. This is how it's different logically. Now,
So when we'll add it, right? So then only we can like Git can track. Before that cannot track.
it can track, means that's what it know there is a file, but to keep track of it means to see what changes happened there, to commit and all, you need to do git add. That's what it means. It can track, but to commit and to move to remote, you have to do git add. That's what it means, right? So if Git doesn't track, it will not give you that information also, right? It's giving you untracked files, right? It will, if Git doesn't know there is a file, it cannot give you that information as well. Git know, but for Git to keep track on it in the sense, it has to add and it has to push, go to commit, then it has to push to remote. If it has to go through this process, it has to be added, right? And now it is in the staging area, and then it says changes to be committed. Changes to be committed means changes not yet committed. Changes are in the staging area. See, always refer it to the diagram as well. Keep this architectural diagram in the mind. To be committed means it is in the staging area. Am I correct? To be committed, it's in the staging area. Now committed. How to commit? Git commit. -m is mandatory. M means message. You have to provide some message to identify your commit, like comments. You might have known comments, right? Comment. You comment it so that you understand at a later point of time what it is. I'm just giving some message. Git commit -m. See, we don't need to provide file names. Whenever you commit, you run this commit command. Whatever in the staging area will be committed. See here. Whatever in the staging, there might be 4 files, 3 files, everything will be committed, right? Then I can say my changes are in local repository. So now tell me, where is this file?
Local repository.
Now
In
the
the local
changes are in
repository.
local repository, yes. Also now if I run git status, see, working tree is clean, means whatever there in your working directory were all committed and placed in local repository. It was clean. Understood the flow, everyone? Shall we do it with another file so that any confusions, any blurriness should be cleared? Yeah,
Yes, we'll try one more.
we'll create with one more file. ls will list the files in that folder. Okay, these are simple Linux commands. We'll have a separate session for them, but small Linux ls cd you can get, you can learn them very easily. Okay, it will list the full files, or else you can also check here. Now let's say I'll create one more file. I'm creating from the user interface. If you are good, you can also do it from command line if you know the commands. So I'm creating one more file, let's say file2. Okay, so now tell me, where is this file2?
Working
Where
directory.
is this file2?
Local
ls
folder, working directory.
means working directory. ls will show the files in the local directory, or else here also you can see both are there, right? But to know like exactly where it is, you can run one more command, git ls files. Git ls files shows the files in the local repository. See, only file1, file2 is not there in local repository. correct? Fine. Okay, now let me do git status. What will git status tell us?
Untrack file, file 2.
Untracked file 2, and the file 2 is said to be in the working directory. See here, untracked file 2. It know there is a file. Okay, but for it to keep track of it, to move to staging, to move to local, you have to do git add. Okay, fine, we'll do that. Git add file 2. Okay, done. Now check the status. Now can you tell me where is this file?
Staging.
I want answers from everyone. Where is this file now?
In the
Yeah.
staging area.
Staging area. It is in the, it says changes to be committed. You can refer to this diagram, also to the architectural diagram. Okay, remember this diagram thoroughly. I'll share you all these, all of these are in the drive. So you can refer that and do the commands to get these basics thorough. So now, okay, fine.
Git
It's
commit.
asking to commit, git commit -1 second commit. Sorry, it's, I wrote n, it's -m, okay? It's not n, it's m. M for message flag. So done, it has committed. Now both the files are in local repository. Working tree is clean. Git ls files will show both the files now. Understood?
Yes.
Okay, there is a question from Kushwant. We need to run the command in Linux only, or we can run it on other area. Kushwant, this is a git bash. Okay, git bash will be installed once you install git. You can run the commands here, or you can run these commands from command prompt also, or else in Visual Studio Code also you can run. We will discuss those things also. Okay, first let's get familiar with the flow. We'll see like other ways to implement it, other interfaces where you can run those commands. Okay, but for now, just get started with git bash. Okay, so yeah. Yeah, that's how the file goes. Like that's how you move your changes from working directory to staging to local. There are many things you can do. You can like you can revert the changes, you can undo the changes. Till now we were just creating the files, right? You can modify the files, you can delete the files. That's how it works in reality. It's not about always creating, right? We will discuss those things also. But before that, let me go through few more commands. See, we have done few commit commands, right? We have run commit command twice. Whenever you run the commit command, okay, it will create a commit ID. Okay, commit ID will be unique. It's a hash code. Okay, it is helpful to revert, or it is helpful in many ways. It's very important. And you can see that list with a git log command. We discussed in the beginning, right? Git log will give you the list of, the complete detailed history of which person made what changes. Let's see that now. Git log. See here, I committed twice. So first commit, this is the commit ID of the first commit. This is the commit ID of the second commit. And the author, how is it getting the name and email ID? See, one more thing, whenever you are running git commit command for the first time, it will ask you for your username and email ID. Okay, the commands also it will show you. You have to run them and put your email ID and name. It's not asking for me because already they were added up here. Okay, just whenever you run, it will ask you for name and email. So whatever name and email you provide, it is tracking with that as an author. And the date, which is very important, the timestamp, right? So 8:23, the system time. This is important, right? So that I know which person made changes where and all. Similarly, the second commit. And if you want to know in detail which person, what changes were done in this commit, isn't it? Which line was modified? You can take this entire commit ID, or else first 7 characters are enough. Okay, then git to show that first 7 characters. It will show you what changes were made. See, just new file was created, that's all. We didn't write any content inside the file, right? So that's what. If you have added some content, it will show that lines also. Right? That's how you know what changes happened on which file at what point of time. Right? So this is the log command. Or else, let's say I just want to see simple log, not this kind of log. You can add one line flag here. See, first 7 characters and the commit message. I have given this message, right? See, this message is very important. We should be giving a reasonable message. Like, let's suppose, okay, I have made these changes for Terraform creating an instance. Okay, I can write that code changes for instance creation. So that at a later point, if I see that log, I understand, because with this number, I cannot memorize it, right? So I can understand, okay, this commit is about making some instance in Terraform, something like that. A good message so that you can understand what this commit is doing at a later point of time.
Hello, Preeti. In the first commit, it is showing just uh, the hash number for the commit hash number. But in the second, it in the bracket there is a head arrow master. What is that one?
Head, and this is the branch name and this is the pointer. We'll discuss branches and pointers later.
Okay, okay.
Okay, by default, you'll be in master branch. What is the master branch and all, we'll discuss later. See, here also it's showing you. Okay, the topmost commit. Head will be at the topmost commit. We'll discuss pointers, branches later. Okay, and yeah, so
Madam, can you
these are
explain once again one line?
which one?
Log
One
one line,
line
log one
will
line.
show you a brief log. Brief log meaning, see, detail log. Git log will show you detail log with a complete commit ID, the author, date, the commit message, everything. But brief log means just the commit ID, commit message. That's all. If you just have a look, want to have a look at a simple log or a brief log, Git log one line flag will do. Clear will help you clear your screen. And if you want to see the list of all the commands we have executed till now, history command will do. See, these are the commands we have executed till now, correct? Of course, we have checked the version, go to the directory, git init, git status, git commit and all. All these commands I will share with you. See, do the hands-on on regular basis. On day one, it might be very simple, but don't ignore it. Yes, yes, Imran. Head is a pointer which points to the topmost, the latest commit in the current branch. We'll discuss those pointers and branches separately. We have a topic on it.
Hey,
Okay.
Preeti, can I get the link to your Google Drive, or are you going to share that later?
Sure, sure. See, here are all the commands, whichever I have executed, right? All these commands will be shared. These are the commands we'll be executing. All these commands are available in the drive. We'll share this drive with you, including the presentation I have used, including like where we have this architectural diagram and all. Okay. So, like I said, already said, you may feel it simple or easy as it is a day one, but still do the hands-on. Okay, if you are like a new, do hands-on twice. Don't hesitate to do hands-on multiple times. Get thorough with this basic flow of Git so that we'll get into the advanced concepts. We'll get into advanced concepts like rebase, reset, conflicts, right? How one person cannot not overriding other changes, how Git is helping us. All those scenarios we are going to take up. Reverts, right? Reset, reverts, lot of things were there. Okay, lot many Git concepts we will be going through. So before that, yes, you have to install your Git and do some hands-on, right? Do the hands-on till this part. And from here, we shall take up in the next session. If you want to have access and if you want to continue from the next class, please complete your registrations by paying the fee. I think you have already the contact numbers. Okay, you can contact Mr. Raj or me and complete your registration to continue from tomorrow. Any more questions you have? Anyone? Okay, Harish has a question. Let's say we are creating 5 files. How to add only 3 files to staging area? You have to do git add those file names, Harish. You have to put those file names whichever you want to add to staging area. Like we are doing git add file 1, git add file 1 space file 2. You can put that way. Or else, if all of your files follow some same pattern, like let's say all are text files, you can give star.txt. Git add star.txt. All the files with the txt extension can be added. Or else, suppose if you want to add all the files in that folder, git add dot. That also will help. If you want to add all the files, git add dot. We'll go through those commands as well. Okay. Today we have discussed about the what version control system is, who have to learn this version control system, architectures of version control systems, then Git architecture in particular. Then we have created local repository, and we have seen the flow, like how to put it in the staging area, how to move to local and all. We didn't go to remote repository set. How to use GitHub and all we'll go. But before that, like I said, we have lot many things to go through. Let me just show you the content of Git which we'll be going through. Just give me a second. See, we are not yet done. Please don't leave, okay? Um, just give me a second, please. These are the numbers you can reach upon. Okay. And
Okay, so one question, Preeti. So, how frequently the DevOps person using those commands like git commit, add? I think mainly the dev people they used to do these things, right?
no. See, like I said, we have Terraform config files, Kubernetes files, Ansible files. How are we version controlling them? We do have lot
But,
of config files, right, as a
but,
DevOps
that, no,
person.
but that is one time somebody will do the changes, right? But,
No,
but
but the
frequently,
Terraform code, whenever you want a new modifications, you will be making changes, right? And also
Mhm.
that's being shared by multiple team members.
Okay.
DevOps team, let's say you have 5 members in a team, right? Today you might be making modifications. Tomorrow others will do modifications. So how does that work? Not only Terraform, Kubernetes manifest files, Ansible files, even simple Jenkins file. We have Jenkins file where we manage the pipeline. Even that should be version controlled. That's mandatory to version control Jenkins file because we need to have versions of the pipelines as well. So if we don't know this, how do we manage all those files, or else how do we handle them, right? So everyone should know this. Developers will be using for managing their code. DevOps teams will be using to manage their config files, Jenkins file, and so on. Definitely we need it.
So so basic.
Module 2 will be taken after module 3, Siddharth. It's about Linux. Okay, after we'll learn Git first, then we'll go for operating system, Linux.
So
Okay.
Preeti,
So,
you're
And
saying
what,
pretty
then
much.
I'm
Sorry, may I
sorry.
say something? What I was
Yeah,
saying is
please.
pretty much you're saying the code files from every step, for example, whether we're using Selenium, monitoring tool, or anything, everything goes in one project folder and that one main
You mean
repo. Is that what you're saying?
you mean on the repository, GitHub repository?
Correct. Everything stays in there, right?
No, not in the same repository. We'll have a separate repository for Terraform config files. We'll have a separate one for Kubernetes manifest files. Sometimes Kubernetes manifest files can be placed in the dev repository also, but it should be definitely in a separate folder because sometimes we apply Terraform Kubernetes manifest files with Argo CD. So definitely we need to put it in a separate repo or at least in a separate folder.
Right, but they all go in one project folder at some point, or no?
No, separate projects, separate folders. So this is the content. Here I have given a content which we'll be going through. We were working on creating repositories, right? And we have to work on rebase, reset, git stash, working with repositories, merging the repositories, working with the conflicts, right? Working with the different kinds of pull with rebase and all. And then working with GitHub where we'll be doing forking, pull requests, how to avoid, like how conflicts arise on GitHub, all those things. Okay,
so
once done, we'll
what are
take
the
up second.
commands? What are the commands we use as of now? So that is still like local repository, right?
Yes, we didn't go to remote yet. Correct. We were still on local.
Okay,
We
so
didn't
like
start remote.
once we commit, so now in local repository, how to move this code to remote? So we have to push it.
Push. Yes, push. Git push. These are all the commands we'll be going through, and these are the commands to push. Okay, we'll go through all of those. Any more questions from anyone?